Welcome to the General Chemistry 2 class. This section is on chemical thermodynamics. This lesson is about the spontaneity of reactions. Let's begin. In this lesson, we will predict the spontaneity of a process based on entropy. A spontaneous reaction is a reaction that occurs on its own, that is, without intervention of an external force. Iron, when exposed to oxygen, is converted to rust, or that is what we call the ferric oxide. The process of rusting is spontaneous. A non-spontaneous reaction is a reaction that occurs in the presence of an outside intervention. Converting rust into iron metal and oxygen gas is a non-spontaneous reaction. This implies that rust particles cannot be converted into iron metal by itself. From the given examples, we can conclude that if a reaction is spontaneous, its reverse is non-spontaneous, and vice versa. The reactions given on the right are spontaneous. From these reactions, we can conclude that the endothermicity or exothermicity of a reaction does not determine its spontaneity. Entropy, denoted by S, is a thermodynamic quantity of randomness or disorder of particles. It is related to the number of possible arrangements for a given quantity of particles. One common unit of entropy is joule per Kelvin. As for the case of molar entropy, one unit is joule per Kelvin mole. As particles become more random, the entropy increases. Standard entropy is the absolute entropy of 1 mole of a substance at standard conditions. 1 atmosphere and 25 degrees Celsius, the table on the right shows the standard entropy of selected substances. Notice that the order given by the solid, followed by the liquid, then gas is arranged in increasing standard entropy. This is due to the increase in the degree of disorder as molecules are brought from solid state to liquid state and to gaseous state. Allotropes of the same elements have different entropies. For instance, diamond has a greater standard entropy at a given temperature than graphite as a result of a greater order of carbon atoms in diamond. Molecules with a greater number of atoms have greater entropies as a result of greater number of molecular motions. Thus, ethane has a greater entropy at a given temperature than methane. Bigger atoms have greater entropies than smaller atoms for having smaller spacing between energy levels. This property of bigger atoms contributes to its higher degree of disorder. Details on this is beyond the scope of this lesson. For instance, neon has a greater entropy than helium since neon is bigger than helium. The entropy of reaction, delta S, is the change in entropy from the initial state to the final state of a reaction or a process. In a reaction, the standard entropy of reaction, standard delta S, of reaction is the difference of standard entropy of the products and that of the reactants. The entropy of a reaction or any process refers to the entropy change of the system, delta S of the system. The delta S of the system alone does not dictate whether a reaction is spontaneous or not. For a spontaneous reaction to occur, the entropy change of the universe, delta S of the universe, which is comprised of delta S of the system, and the entropy change of the surroundings, or delta S of the surroundings, must be positive or greater than 0. If it's negative or less than 0, the reaction is non-spontaneous. Examples of spontaneous reactions or processes with delta S of the universe greater than 0 are as follows. Endothermic phase changes: fusion, evaporation, sublimation, above melting, boiling, or sublimation temperature. Exothermic phase changes: freezing, condensation, deposition, below freezing, condensation, or deposition temperature. Dissolution of a solute in a solvent, neutralization of reaction of an acid with a base, and evolution of gaseous products. A thorough discussion on the spontaneity of these processes is discussed in the next lesson. Example number 1. Determine which of the following reactions is or are spontaneous or non-spontaneous. Solution. The first reaction is neutralization, which involves evolution of a gas. So delta S of the universe is greater than 0. Therefore, the reaction is spontaneous. The second process involves boiling water at 1 atmosphere and below its normal boiling point, 100 degrees Celsius. Such process occurs spontaneously, only at its boiling point. Below the normal boiling point, delta S of the universe is less than 0. Thus, the reaction is non-spontaneous. The third process is a dissolution of glucose in water. During dissolution, solute and solvent molecules are brought from the unmixed or ordered state of the mixed disordered state. Thus, the reaction is spontaneous. As a conclusion, to summarize, a spontaneous reaction it is a reaction that can occur on its own. A spontaneous reaction occurs only in the presence of an outside intervention. Entropy is a measure of disorder or randomness of particles. A spontaneous reaction has a positive entropy change of the universe. That is all. Thank you.